I'm going to find the amplitude, period, and frequency of a weighted spring that follows this sine function that we're given, where t is representing time. I'm also going to end up sketching the graph very roughly over the domain 0 to 1. Now, first of all, domain is all of your x values, which means the graph is going to exist from an x value of 0 to an x value of 1. Now, in this case, they're using t instead of x. Please understand those are the same thing. So the x-axis is going to represent seconds in this case. Before I actually get into doing the problem, you need to understand why a weighted spring is going to follow a periodic function. So I have these pictures of a spring. It's starting over here on the left at what's called zero displacement. So I have this line drawn down the middle to help demonstrate displacement. Because this is a sine function, our starting point at 0 seconds is zero displacement. That means the spring where I just drew that arrow has not gone anywhere. That's its starting point. But then, as the spring moves, it's going to bounce up and it's going to bounce down. So it stretches and it compresses. So the first thing that this spring is going to do is bounce up. It's going to recoil, and then it's going to start to stretch all the way down before it starts to bounce back up again. And this pattern goes on forever. So if I trace where that weighted spring is located, we actually have a sine function. And remember, these functions do go on forever. This is just one period of the sine function, or one period of this spring going through that pattern of starting at zero displacement, going up here to maximum displacement, and then coming back down through zero displacement again, stretching down, and then back to zero. So now we're actually going to graph the function, and it should look similar to what I just drew with the springs. First thing we're going to find is the amplitude. That should be easy. It's just your A value in front. The amplitude is 10. That means the graph is going to go up to a y value of 10 and down to a y value of negative 10. On our springs, this would be 10. This down here would be negative 10. Next is the period. B is not the period, but we use it to find the period. Two pi over b is the formula for period. We find the absolute value of b to ensure that we have a positive period, because period is the length of time that it takes to get through one cycle of the graph. So the period is 2 pi divided by 4 pi, which reduces to 1/2. So what we just found is this sine function goes through one full cycle in half a second. The last part is to find the frequency, which should be easy if you know the period. All we're doing is finding the reciprocal of the period, which means we're just flipping that fraction. So our frequency is 2. The frequency is how many cycles of that graph occur in 1 unit of time. Time is measured in seconds, which means we're going to have 2 cycles of this sine function in 1 second. Now I'm going to very roughly sketch this graph, starting at 0, 0, since sine starts with 0 displacement. Remember, 1 period is half a second. So by the time I get to a quarter of a second, the graph should go up to 10 and then back down to 0 displacement. And then between a quarter of a second and half a second, we should finish that cycle by going down to -10 and back to 0. This is 1 period. Now remember, the frequency told us that we should have this pattern twice in 1 second, so I'm going to draw it again. I told you it's a very rough graph, but you get the point.